Welcome back for another deep dive. This time, we're going to be tackling the world of modern software architecture.
Oh, awesome.
Yeah, and I have to admit, when I first saw this topic, software architecture, my eyes kind of glazed over a bit.
Yeah.
But trust me, the material you sent my way for this is actually a lot more interesting than I initially thought it would be.
What's fascinating is these lectures are not shying away from the tough questions like,
Yeah.
is an architect even necessary?
Mm.
How does all this relate to Agile? And what's this about comparing software architecture to art?
Right, they jump right into the deep end with that whole architect in the tower
Yeah.
analogy,
Yeah.
that idea that architects are just these isolated figures that kind of just slow things down with like a bunch of unnecessary complexity.
Yeah, and that image really fuels the skepticism around
Mm.
whether we even need architects anymore, especially with the rise of agile development
Right.
and this idea that the perfect architecture will just kind of emerge organically.
Emergent architecture.
Yeah.
That sounds really tempting.
Right. Who wouldn't want to avoid all that upfront design work? But something tells me it's not always that simple. Like, what could go wrong with that approach?
Well, if you think about it, if you're not consciously making architectural decisions, you're still making them. You're just making them by default.
Right.
And the lectures call this accidental architecture. And it can often lead to systems that are difficult to maintain, scale, or even adapt to changing needs.
So it's like building a house without a blueprint.
Exactly.
You might end up with something that works, but it'll probably be full of weird quirks and structural problems down the line.
Totally.
So how do we avoid ending up in that accidental architecture territory?
Well, the key is to find the right balance.
Okay.
We need to be deliberate about our architectural choices, but we also need to be flexible and responsive to change. And the lectures make a great point about this. The ideal architecture really depends heavily on the context of the project and the organization.
Makes sense.
Like a massive enterprise project with hundreds of developers probably needs a much more defined architecture up front than like a small startup building an MVP.
Exactly. It's about finding the sweet spot for your situation.
Right.
For example, if you're relying heavily on external contractors,
Mm-hmm.
you're going to need clearer architectural guidelines right from the start, but with a small, experienced team working on a well-defined problem,
Yeah.
you might have a lot more flexibility.
Okay, so lesson one. There is no one-size-fits-all approach to architecture. We need to assess the context, understand the constraints, and make informed choices.
Right.
Okay, so we've kind of established that architects still have a role to play.
Yeah.
But what about the relationship with programmers? Are programmers just code monkeys, or are they designers too?
That's a really good question. And it's one the lectures tackle head on.
Okay.
They use this analogy of software development being like the construction industry,
Okay.
with architects creating blueprints and engineers doing detailed designs, and then construction workers actually building the structure.
Oh, right.
And at first glance, it seems like programmers are the construction workers just following instructions, right?
Right.
But that doesn't seem quite right, does it?
No, not really.
Programmers are doing a lot more than blindly executing a plan.
Yeah, they are.
The lectures actually challenge this whole analogy by pointing out that the real builders in software are the compilers and the build pipelines.
Oh, interesting.
We're the ones that actually take the code and turn it into a functioning system.
Okay, so if compilers are the builders, then what does that make programmers?
Designers.
Okay.
They take the high-level concepts from the architect, and then they figure out how to translate those into code that can actually be built.
Uh-huh.
It's a creative process that involves problem-solving, decision-making, and, yes, even artistry.
That's a really interesting way to look at it.
Right.
It shifts the focus from programmers just being code monkeys to them being the creative force behind the software's detailed design.
And that's a crucial distinction. It highlights the importance of empowering programmers to make design decisions
Right.
and contribute to the overall architecture.
Okay, speaking of architecture, I'm still a bit fuzzy on the term itself.
Uh-huh.
It seems like everyone has a different definition of what architecture actually means.
Yeah.
Have you found a way to kind of cut through the noise?
The lectures do a great job of kind of simplifying this by breaking down architecture into three main categories: a set of decisions,
Okay.
a description of the system's structure,
Okay.
and a design process.
Okay, so three different kind of facets of the same concept.
Yeah,
Can you give me some concrete examples? I think that would help me to kind of wrap my head around this.
absolutely. So think about the different levels of architects we mentioned earlier:
Mm.
enterprise, solution, and application.
Yeah.
Each level makes decisions within a specific scope,
Mm-hmm.
and those decisions, in turn, kind of shape the system structure.
Okay, so like an enterprise architect is thinking about things like the overall technology strategy, while an application architect is more focused on the design of a specific software application.
Right.
And then all of those decisions are reflected in the system's structure. So how it's organized, what components it's made of, and how those components interact. Is that right?
You got it. And the lectures highlight the C4 model,
Okay.
which is a visualization technique for representing those different levels of a system.
Okay.
It's like having a set of maps that allow you to zoom in and out to see different levels of detail, from the system's context all the way down to the individual components.
Okay, now that sounds useful. I have definitely been in those situations where I felt lost in a new code base,
Yeah.
wishing I had like a map to help me understand how it all fit together.
That's exactly what the C4 model aims to provide.
Okay.
It's designed to be user-friendly,
Hmm.
even for non-technical stakeholders,
Uh-huh.
which makes it a great tool for communication and collaboration.
Uh-huh.
And unlike traditional modeling languages like UML, which can feel a bit clunky and overwhelming,
Mm-hmm.
the C4 model is designed to be lightweight and easy to update, making it ideal for agile environments.
So it's a way to kind of bring clarity and transparency to the architecture,
Yeah,
which is especially important in today's like fast-paced world of software development.
absolutely.
Tell me more about these C4 diagrams. Like what kind of information do they capture?
Well, the lectures use a banking platform example to illustrate the different levels of C4 diagrams. So at the highest level, you have the context diagram,
Okay.
which shows the system's overall purpose, its users, and the other systems that it interacts with.
Okay.
So in this case, you'd see things like the mobile app, the API, the database, and of course, the customers using the system.
That's a great starting point. It gives you that kind of bird's eye view of the landscape.
Yeah.
What about the next level down?
So the next level, C2, zooms in to show the containers within the system.
Okay.
So in that banking example, these containers might be things like the mobile app container, the API container, and the database container. Each container has its own responsibilities, technology choices, and communication patterns.
So it's like breaking down the city into its different neighborhoods,
Yes.
each with its own distinct character and function.
Right.
And then can we zoom in even further?
Absolutely. The C3 level shows the components within each container.
Okay.
So if we zoomed into the API container,
Yeah.
we might see components for user authentication, account management, and transaction processing.
And I'm guessing the C4 level takes us all the way down to the code level.
You got it. But this level is optional
Okay.
because it can get very detailed
Right, that's okay.
and change frequently.
Yeah.
It's often more useful to stay at those higher levels
Right.
to understand the overall architecture and how the different pieces fit together.
So C4 is like this set of nested maps, each one providing more detail as you zoom in.
Exactly.
That's a great way to kind of visualize the structure of a complex system.
And one of the coolest things about C4 is that it can integrate with other architectural documentation frameworks like Arc42, which provides a more comprehensive template for describing your architecture,
Okay.
or even with traditional UML diagrams,
Right.
if needed.
Gotcha.
It's really flexible and adaptable.
The C4 model is starting to sound like a must-have tool for any software architect.
Yeah,
It's like having GPS for navigating the complexity of your code base.
I like that.
But even with a great map, you still need to know like where you're going, right?
Right.
So how do architects decide what that destination should be for the system's design?
That's where the concept of architectural drivers comes in.
Okay.
These drivers are the forces that shape the architecture, the reasons behind the decisions we make about the system's design.
Okay, so we're talking about like the why behind the what of the architecture.
Exactly.
Can you give me like an example? What might be an architectural driver for our banking system?
Well, security would be a major driver in that context, wouldn't it? You'd want to make sure that user data is protected and transactions are secure.
Of course. Yeah.
Right. And that driver would influence decisions about encryption, authentication, authorization, and the overall system design.
That makes perfect sense. Security is definitely a top priority for any banking system.
Yeah.
Are there other types of drivers that architects need to consider?
Absolutely. The lectures group drivers into 5 main categories: functional requirements, quality attributes, design constraints, conventions, and project goals.
Okay, let's unpack those a bit.
Sure.
Functional requirements seem pretty straightforward, like what the system needs to do.
Right.
What about quality attributes?
Those are all about how well the system does what it does.
Okay.
So scalability is a classic example.
Mm-hmm.
Can the system handle a growing number of users and transactions without falling apart? Performance is another one. How quickly does the system respond to user requests?
So those quality attributes are directly impacting like the user experience
Yeah.
and the overall success of the system.
Exactly.
Okay, what about design constraints? Those sound a bit more like limitations.
They are. They're the real-world factors that restrict our design choices.
Okay.
So think about budget limitations.
Mm-hmm.
You might have to choose a less expensive technology, even if it's not ideal. Or maybe there are regulatory requirements that dictate how certain data must be handled.
Ah, so those are like the rules of the game that we have to play by.
Exactly.
And what about conventions?
Conventions are the established practices and standards within an organization or a technology community.
Okay.
So, for example, your company might have a convention of using a specific programming language or a particular cloud platform.
So those conventions help to kind of ensure consistency
Yeah,
and reduce complexity, which is always a good thing.
absolutely.
And finally, we have project goals. Those seem pretty self-explanatory.
They are, but they're crucial
Okay.
because they set the overall direction for the architecture. Is this a quick prototype?
Hmm.
A minimum viable product to test the market, or a mission-critical system that needs to be rock solid from day one?
Right.
Each goal is going to lead to different architectural decisions.
It's like choosing the right transportation for a journey.
Yeah.
You wouldn't take a bicycle across the country, and you probably wouldn't rent a moving truck to pick up a pizza.
Exactly.
So understanding those project goals gives you a clear destination
Right.
and helps you choose the right architectural vehicle to get there.
I like that.
Okay, so we've got these 5 categories of drivers,
Mm-hmm.
but where do they actually come from?
That's a great question.
They don't just magically appear, right?
You're absolutely right. Drivers come from people.
Okay.
The lectures emphasize the importance of stakeholder mapping, meaning talking to all the people who have a stake in the project and understanding their perspectives and priorities.
So it's not just about talking to the developers,
Right.
but also the business users, the project sponsors, the operations team, maybe even legal and compliance folks.
All of the above.
Yeah.
Exactly.
Okay, so each stakeholder will have their own kind of set of drivers.
Right.
Like the business users might be more focused on the functional requirements, while the operations team might prioritize scalability and reliability.
Makes sense.
But how do we make sure we're getting useful information from these stakeholders? Just asking, like, is this important?
Yeah.
Seems like a recipe for getting a lot of yes answers.
You're right. The lectures suggest framing questions in a way that reveals priorities and potential trade-offs.
Okay.
So instead of asking, is security important?
Uh-huh.
You might ask, which is more important,
Yeah.
faster development or tighter security?
Ah, so you're forcing them to make a choice.
Right.
You're getting a clear understanding of what truly matters.
Exactly.
And by talking to a diverse group of stakeholders,
Right.
we can uncover like the full spectrum of drivers that will shape the architecture.
Totally.
But, even with the best intentions, people can interpret things differently. So how do we ensure everyone on the team is truly on the same page when it comes to these drivers?
That is a really great point.
Like, we might all agree that scalability is important,
Yeah.
but what does that actually mean in concrete terms? How do we measure it? How do we know if we've achieved it?
That's where the concept of metrics-driven architecture comes in.
Okay.
So instead of relying on subjective interpretations,
Mm-hmm.
we use metrics to quantify the drivers and
Yeah.
create a shared understanding.
Okay. I like where this is going.
Yeah.
Can you give me an example of how this might work in practice?
Let's go back to our banking platform and that scalability driver we talked about.
Okay.
So instead of just saying, the system needs to be scalable,
Right.
we define a specific metric, like the number of transactions per second that the system can handle.
Okay.
We set target values for that metric.
So we're not just talking about scalability in general. We're defining a measurable goal that everyone can understand and work toward.
Exactly.
What would that look like for the banking system?
We might say the system should be able to handle at least 10,000 transactions per second under peak load.
Okay.
That gives us a clear, quantifiable target to aim for.
That's much more concrete than just saying it needs to be scalable.
Exactly.
What about other drivers? Can we apply metrics to those as well?
Absolutely. Take testability, for instance.
Okay.
We could define a metric for code coverage,
Uh-huh.
which is the percentage of code that's covered by automated tests.
Right.
We might aim for 90% code coverage
Okay.
as a measure of testability.
And by tracking these metrics over time,
Yeah.
we can see if we're making progress towards our architectural goals.
Exactly. It provides a feedback loop that allows us to adjust our approach as needed.
Right.
But There's a nuance here.
Right.
The lectures point out a distinction between quality metrics and technical debt metrics.
Okay, I'm intrigued. Tell me more about this distinction.
So quality metrics are those where higher is generally better.
Okay.
Code coverage, performance, user satisfaction. We want those numbers to be as high as possible.
Makes sense. What about technical debt metrics?
Those are the ones where lower is better.
Okay.
Think about code complexity, the number of bugs, or even something like build time.
So for technical debt metrics, we want to see those numbers decrease over time.
Exactly.
The lectures mention like a backup time target that is longer than the current backup time.
Yeah,
And that seems kind of counterintuitive. Wouldn't we want the backup to be like as fast as possible?
that's a great question, and it highlights the importance of understanding the context of the metric.
Okay.
It might seem odd to aim for a longer backup time, but in that specific case, it actually represented an improvement
Okay.
because they were taking into account the expected data growth.
Uh-huh.
So even though the backup might take longer in absolute terms, it's still within an acceptable range, considering that larger data volume.
So it's like saying, yes, my commute is a bit longer now, but that's because I moved to a bigger house with a better backyard.
Exact.
It's all about understanding the context of the metric and what it represents. But speaking of context, there's one more big question I have.
Yeah.
How does all this fit in with like the agile world? Architecture seems to imply constraints and upfront planning, while agility is all about flexibility and adapting to change.
Right.
How do we reconcile those two seemingly opposing forces?
That's a tension a lot of teams struggle with, right?
Right.
The lectures offer a really interesting perspective on this by drawing a parallel to the world of art.
Okay.
They quote Stravinsky, who said that the more constraints he imposed on himself, the freer he became in his creativity.
Oh, wow.
And Da Vinci believed that art thrives within limitations.
Interesting.
So the idea is that constraints, when chosen wisely,
Yeah.
can actually enhance creativity rather than stifle it.
So how does that apply to software architecture?
Well, well-chosen architectural decisions can actually enhance agility.
Okay.
They provide a framework for flexibility and growth, much like a musical score or a painting's composition. Provides structure for artistic expression.
That's a really thought-provoking idea.
Right.
So it's not about imposing rigid rules that prevent us from adapting. It's about creating a solid foundation that allows us to evolve and grow in a more controlled way.
Exactly. And the lectures give some concrete examples of how this might look in practice.
Okay.
Dividing a system into autonomous subsystems, for example,
Mm.
allows teams to work independently and make changes without affecting other parts of the system. Automating deployment processes reduces the risk and overhead of releasing new features, allowing for faster iteration.
Right.
And establishing a consistent technology stack simplifies development and maintenance, freeing up time and energy for more creative work.
Those all sound like really smart choices that would enable teams to move faster and adapt more easily to those changing needs.
Right.
But I'm curious, how do we find that balance between making those decisions up front and leaving room for flexibility? Is there a sweet spot?
The lectures emphasize finding the last responsible moment to make architectural decisions. So it's about delaying decisions until you have enough information to make an informed choice, rather than jumping to conclusions based on assumptions or incomplete data.
So it's a bit like that saying, measure twice, cut once.
Exactly.
We want to gather as much information as possible before we commit to like a particular path.
It's about being deliberate, but
Yes.
also adaptable.
Right.
Recognizing that the world of software development is constantly changing, and we need to be able to respond to those changes without sacrificing the integrity of our architecture.
Right.
Yeah.
So
It's a tricky balance,
it is.
but it's definitely achievable
Okay.
with the right mindset and the right approach.
Okay.
So I think we've covered a lot of ground here.
I have.
We've talked about,
Yeah.
the need for architects,
Uh-huh.
the different types of drivers,
Right.
and this idea of finding the last responsible moment to
Right.
make those decisions.
Yeah, and I think it's clear that modern software architecture
Yeah.
is much more nuanced than just drawing boxes and arrows on a whiteboard.
Totally. It's about understanding the interplay of those technical factors,
Right.
human factors, and those business goals.
And ultimately, it's about creating systems that deliver real value
Exactly.
to the users
To the users.
and that can adapt and evolve
Yeah.
as the world around them changes.
Couldn't have said it better myself.
Yeah.
All right. So let's take a quick break.
Okay.
And when we come back,
Yeah.
we'll dive into some more practical techniques
Sounds good.
for actually putting these principles
Yeah.
into action.
I'm excited.
E2.
All right. Okay. So I'm starting to see how important these architectural drivers are.
Yeah.
But I have to admit, even with all these diagrams and metrics,
Uh-huh.
it's still tough to grasp the big picture sometimes.
Right.
Is there a way to make this whole process more tangible, more hands-on?
You've hit on a crucial point.
Okay.
Architecture isn't just about, like, abstract concepts and diagrams. It's about understanding how a system behaves in the real world.
Right.
And that's where event storming comes in.
Event storming.
It's this fantastic workshop-based technique
Okay.
that brings together the technical and business folks
Okay.
to map out a system's behavior in a very visual, collaborative way.
Wait, a workshop? That sounds way more engaging than just staring at diagrams all day.
Right?
How does that work?
Imagine a big whiteboard
Okay.
covered in colorful sticky notes.
Okay.
Each color represents a different element of the system, like an event, a command, or an external system.
Mm-hmm.
It's like building a living, breathing model of the system, one sticky note at a time.
That sounds a lot more dynamic than traditional documentation.
I
But
mean-
what kind of events are we talking about here?
Domain events are the heart of it.
Okay.
These are the things that happen in the system,
Okay.
like order placed, payment processed, or inventory updated.
Okay.
They're usually written in the past tense
Mm.
because they represent something that has already happened.
So we're capturing the system's history, the key moments that kind of define its operation. So we're basically telling the story of the system, right?
Exactly.
Hmm.
And by laying out these events chronologically on the whiteboard, we can start to see the flow of information and the dependencies between different parts of the system.
Okay. I'm starting to see the power of this.
Yeah.
But events don't just happen spontaneously, right?
No.
Something has to trigger them.
That's where commands come in.
Okay.
These are the actions or requests that initiate those events,
Uh-huh.
like place order, process payment, or update inventory.
Okay.
In an event storming session, we typically use blue sticky notes for commands and place them to the left of the events they trigger, connected by arrows to show those cause and effect relationships.
So we're not just listing events, but we're also understanding what triggers them and how those actions kind of ripple through the system.
Right.
This is starting to feel like a detective story, like we're tracing the chain of events
Uh-huh.
to understand how the system works.
I love that analogy. And just like a good detective, we're looking for patterns, connections, and potential problems.
Right.
As we build this map of events and commands,
Yeah.
we start to see groups of related elements emerge.
Okay.
These groups represent aggregates,
Oh.
which are cohesive units of data and behavior within the system. They're often tied to key business entities.
So if we're building that e-commerce platform we talked about earlier, an aggregate might be something like an order or a customer, right?
You got it.
It encapsulates all the events and commands related to that specific entity.
And by visualizing these aggregates,
Yeah.
we start to see how the different pieces of the system fit together and where the boundaries between them lie.
Okay.
It's like putting together a puzzle and seeing the bigger picture emerge from those individual pieces.
This is so cool.
Yeah.
We're literally building a visual map of the system's behavior.
Right.
And we haven't even written a single line of code yet.
And the best part is,
Yeah.
it's a collaborative process.
Yeah. Okay.
You've got developers, business analysts, domain experts,
Mm.
stakeholders,
Mhm.
all working together, sharing their knowledge and contributing to the map.
That sounds like a great way to kind of break down silos
Clearly.
and build that shared understanding of the system.
Yeah.
But I'm still curious how this connects back to those architectural decisions we were talking about earlier.
Oh, yeah.
How does event storming help us to actually make those choices?
That's where it gets really interesting.
Yeah,
By
see.
visualizing the system's behavior through event storming,
Mm-hmm.
we gain insights that directly inform our architectural choices.
Okay.
So,
Yeah.
for example, we can see the key business processes
Yeah.
that drive the system
Right.
and understand the dependencies between them.
So we're not just understanding what the system does.
Right.
We're understanding how it does it and what the key workflows and interactions are.
Exactly. And that knowledge is crucial
Yeah.
for defining the system's boundaries,
Okay.
deciding how to decompose it into smaller, more manageable units,
Yeah.
and choosing the right integration patterns.
It's like we're uncovering the system's DNA,
Huh.
its essential building blocks, and the relationships between them.
I like it.
And that understanding gives us like a blueprint for how to actually design and implement it effectively.
You're getting it.
Okay.
Event storming also helps us
Yeah.
to identify potential bottlenecks
Okay.
or performance issues.
Right.
So, for example, if a single event triggers a cascade of other events,
Uh-huh.
it might indicate a scalability challenge
Okay.
that we need to address in our architecture.
So we're not just identifying what the system does, we're also looking at where it might break down or struggle to keep up.
Yeah,
It's like stress testing the system before we even build it.
exactly. And by thinking about these issues early on, we can avoid costly rework later.
Right, of course.
Event storming also helps us to see the flow of data
Okay.
and identify potential areas for data consistency issues or transactional boundaries.
So we're not just mapping the events themselves,
Right.
but also like the data that's being created, modified, and passed around as a result of those events.
Totally.
That's crucial for building a system that's reliable and maintains data integrity.
Absolutely. And by understanding the communication patterns that emerge from the event storm, we can make informed choices about how different parts of the system should communicate with each other.
Okay.
Shall we use synchronous or asynchronous communication, message queues, APIs?
Wow. It's amazing how much information we can kind of extract from this simple exercise
Right.
of mapping out events on a whiteboard.
Totally.
Like we're getting this holistic view of the system and its behavior.
And that holistic view is incredibly valuable
Yeah.
for making those informed architectural decisions.
But remember, we talked about those different levels of architects,
Yeah.
enterprise, solution, application.
Uh.
Well, there's also a type of event storming
Yeah.
that's particularly useful at the enterprise level.
Exactly.
You're talking about big picture event storming.
You got it.
The lectures mentioned it briefly.
So while that standard event storming we've been discussing
Uh-huh.
is great for deep diving into a specific part of the system,
Right.
big picture event storming zooms out to capture the system's overall context
Okay.
and its interactions with the external world.
Yeah.
It's especially helpful when you're dealing with like really complex systems
Yeah.
or when you need to align different teams or departments around a shared vision.
So it's like creating a map of the entire city, including the surrounding suburbs and transportation networks,
Yeah.
rather than just focusing on a single neighborhood.
That's a great way to put it. In big picture event storming,
Yeah.
we start by identifying those key external systems,
Okay.
like customers, suppliers, regulatory bodies,
Uh-huh.
or even other departments within the organization.
Right.
We then map out the events that flow between our system and those external systems,
Okay.
capturing those big picture interactions and dependencies.
So we're not just looking at the internal workings of our system, but also its role in that larger ecosystem.
Exactly.
That seems crucial for making strategic decisions about integrations, APIs,
Yeah.
and the overall boundaries of the system.
It's a powerful way to understand the system's place in the world
Right.
and identify potential integration points and challenges early on.
This is incredibly insightful.
Yeah.
It seems like event storming, whether in its standard form or the big picture variation, is like an invaluable tool for architects and developers alike.
Yeah.
It's not just about understanding what the system does, but gaining like a deeper understanding of its behavior and its context.
I couldn't agree more.
Okay, so event storming provides this rich, shared understanding that can guide our architectural decisions and help us build better systems.
Absolutely.
Speaking of building better systems,
Yeah.
the lectures also touched on this concept of domain-driven design.
Yeah. DDD.
And it seemed like more than just like a technical approach, it felt almost philosophical. How does that fit into our discussion of architecture and event storming?
You're right. Domain-driven design, or DDD, is more than just a set of techniques.
Okay.
It's a way of thinking about software development that puts the focus on deeply understanding the business domain
Uh-huh.
and reflecting that understanding in the code.
Okay.
It's about bridging the gap between the technical world and the business world.
That gap can definitely be a problem.
Oh, for sure.
I've seen so many projects where developers and business stakeholders are practically speaking different languages.
Exactly. And that's where DDD comes in.
Okay.
It emphasizes close collaboration between developers and domain experts to build a shared understanding of the business concepts, processes, and terminology.
Okay.
This shared understanding then becomes the foundation for the system's design and architecture.
So we're not just building software.
Right.
We're creating like a model of the business itself in code.
Yeah.
How does that actually work in practice?
So DDD provides a set of principles and patterns for modeling the business domain and ensuring that the code reflects that model accurately.
Mm-hmm.
One key concept is the idea of bounded contexts.
Bounded context.
Remember those aggregates we were talking about in event storming?
Yeah, this cohesive units of data and behavior.
Well, in DDD, a bounded context is essentially a boundary around a specific part of the business domain
Okay.
where a particular model applies.
Okay.
It's a way of breaking down a complex system into smaller, more manageable pieces,
Uh-huh.
each with its own clear focus and set of concepts.
So instead of trying to create a single monolithic model of the entire business,
Right.
we divide it into these smaller, more focused models
Yeah.
that reflect those different areas of the business.
Exactly.
Okay.
And each bounded context
Oh.
has its own ubiquitous language.
Okay.
This is a set of terms and concepts
Yeah.
that are shared and understood by everyone involved in that context,
Okay.
both technical and non-technical.
Right.
This shared language is crucial for avoiding misunderstandings and ensuring that everyone is on the same page.
It's like having a common dictionary for each area of the business.
Yeah.
And making sure we're all speaking the same language and avoiding those frustrating lost in translation moments.
Precisely.
Yeah.
And from an architectural perspective,
Huh?
bounded contexts often translate into separate modules, services, or even entire applications. They help us to decouple different areas of functionality,
Right.
making the system more modular, adaptable, and resilient to change.
That makes sense.
Yeah.
If each bounded context is like this self-contained unit,
Right.
we can make changes within one context without having to worry about breaking things in another context.
Exactly.
It's like those Lego blocks.
Yeah.
You can build these complex structures by combining those smaller independent pieces.
I love that analogy.
But I'm still a bit fuzzy on how event storming and DDD connect.
Okay.
They seem like separate concepts.
Yeah.
But I sense that there's like a deeper relationship there.
You're right. They are distinct concepts,
Yeah.
but they complement each other beautifully.
Okay.
Remember how we said that event storming helps us to identify those aggregates?
Yeah.
Well, those aggregates often provide natural boundaries for bounded contexts.
So by mapping out the events and aggregates, we're essentially revealing the potential boundaries of those bounded contexts.
Yeah.
It's like event storming helps us to see the natural structure of the business domain,
Right.
which then informs how we define those bounded contexts in DDD.
Exactly. Event storming gives us this dynamic visual way to understand the system's behavior, while DDD provides the principles and patterns for translating that understanding into a well-structured and maintainable code base.
Right.
They work together to create a system that accurately reflects the business domain
Yeah.
and can evolve gracefully over time.
This is so cool.
Ah,
like
yeah.
we're combining the best of both worlds.
Yeah.
The agility and insight of event storming with like the structured rigor of DDB.
And when we combine these approaches with all the other principles we've been discussing,
Right.
metrics-driven development, stakeholder mapping, finding the last responsible moment for decisions,
Yeah.
we're creating this really powerful framework for
Right.
building adaptable, resilient, and truly valuable software systems.
I'm really starting to see the bigger picture here.
Yeah.
It's not just about choosing the right technology stack or writing clean code.
Right.
It's about understanding the human element,
Yeah.
collaborating effectively,
Absolutely.
and creating a system that truly reflects the needs and goals of the business.
You've hit the nail on the head.
Yeah.
Modern software architecture is this holistic discipline that encompasses technical expertise, human collaboration, and a deep understanding of the business domain.
Yeah.
It's about creating systems that are not only technically sound,
Mm-hmm.
but also adaptable, resilient, and truly valuable to their users.
Absolutely, yeah. As we've been talking about all these techniques and principles,
Yeah.
I've realized something. We spent like a lot of time focusing on the technical aspects of architecture,
Right.
but we haven't really talked about like the people involved.
Yeah.
And building software is ultimately a human endeavor, isn't it?
You're absolutely right. The lectures actually emphasize this point. They say that even the most brilliant architecture will fail
Right.
if you don't have the right people
Yeah.
and the right culture to support
Right.
it.
That makes a lot of sense.
Right.
You could have like the perfect blueprint, but if you don't have those skilled builders who can work together effectively,
Yeah,
the project's doomed from the start.
totally.
So what kind of human factors do the lectures highlight?
Well, they talk a lot about the importance of leadership,
Okay.
specifically having a strong technical leader who can guide the team, make those tough architectural decisions, and inspire others to do their best work.
So we're not just talking about like a brilliant coder.
Right.
We're talking about someone who can also communicate effectively, build consensus, and navigate the complexities of human interaction.
Totally.
It's a tall order.
It is. And this leader,
Yeah.
often the architect,
Mhm.
needs to be like a bridge
Yeah.
between the technical world
Right.
and the business world.
Yeah.
They need to understand the technical constraints,
Yeah.
but also the business goals
Right.
and how the architecture can support those goals.
It's almost like being a bilingual translator, fluent in both the language of code and the language of business.
That's a great analogy.
Right.
And this ability to translate between those two worlds is crucial for ensuring that the architecture actually aligns with the business needs
Right.
and that the technical decisions make sense from a business perspective.
Of course.
But strong leadership is just one piece of the puzzle.
Yeah.
The lectures also stress the importance of teamwork, communication, and a shared understanding within the team.
That resonates with my experience too. I've seen firsthand how a lack of communication or a culture of blame can just sabotage even the most well-intentioned projects.
Absolutely.
So what are some practical tips for building that kind of positive team culture?
Well, the lectures highlight the importance of clear, concise communication.
Okay.
This means using plain language, avoiding jargon, and making sure that everyone's on the same page.
Right.
It also means documenting decisions, using visualizations to communicate those complex concepts,
Right.
and fostering a culture of open feedback and constructive criticism.
So it's not just about what we communicate, but also how we communicate it.
Exactly.
We need to be intentional about creating an environment where people feel comfortable sharing their ideas, asking questions, and raising concerns.
Yeah, I couldn't agree more.
Right. And this kind of open communication
Yeah,
is essential for building trust and collaboration within the team.
absolutely.
When people feel like they're being heard and their opinions are valued,
Yeah,
they're more likely to be engaged and committed to the project's success.
totally.
It sounds like building a strong team culture is just as important as choosing the right technology stack or following those latest architectural patterns.
I think so too.
But let's talk about individual skills for a moment.
Okay.
What kind of expertise do we need to cultivate within the team to build and maintain like a modern software architecture?
Well, the lectures emphasize the importance of both breadth and depth of skills.
Okay.
On the one hand, team members need a solid understanding of fundamental software engineering principles, design patterns, and architectural styles.
So strong foundation in the basics is essential.
Yes.
But what about the depth?
Yeah.
What kind of specialized skills are in demand?
Well, modern systems often involve like a huge range of technologies.
Right.
From cloud platforms and databases
Yeah.
to front-end frameworks and machine learning algorithms.
Right.
You need people who have that deep expertise in these specific areas
Right.
and can make those informed decisions about how to leverage them effectively.
So it's like saying you need generalists who understand the overall structure of the house,
Right.
but you also need specialists who are experts in plumbing, electrical wiring, or roofing.
Exactly.
Well-
And the team needs a balance of these skills
Yeah.
to effectively address the various challenges of building and maintaining like a complex system.
Of course.
And just as important as technical skills is a mindset of continuous learning.
Right.
The world of software development is constantly evolving.
Yeah.
So we need to be adaptable, curious, and willing to embrace new ideas and technologies.
This has been such an eye-opening deep dive.
It has.
I feel like we've covered so much ground.
I have.
From the role of the architect and the importance of drivers to the power of event storming and domain-driven design.
Yeah, we've been through a lot.
But as we wrap up,
Yeah.
I want to leave our listeners with like one key takeaway.
Okay.
If they could only remember one thing from this entire deep dive,
Yeah.
what would it be?
I think the most important takeaway is this. Modern software architecture is not just about technology.
Right.
It's about people.
Mm-hmm.
It's about collaboration.
Yeah.
And it's about a deep understanding of the business domain you're working in.
Right.
If you can bring those elements together, you'll be well on your way to building systems that are not only technically sound, but adaptable, resilient,
Yeah.
and truly valuable to their users.
Beautifully said. And on that note, we'll wrap up this deep dive into the world of modern software architecture.
Great.
We hope you've enjoyed this journey as much as we have.
I know I have.
Keep exploring, keep learning, and keep building amazing things.